and we have been working with them. Some of them here are lists, right? Set, tuple, dictionary, and any other one, or they are these. Anyone can say something. So basically, for built-in data structures for Python, this is what we are going to see today. We are going to see list, tuple, set, dictionary. These are some of the more or less kind of data structure you will see while using the Python. So we'll go over through them so that when we go to chapter 3 doing other stuff in NumPy and Pandas, we will have a very good idea how to work with them. So now the first one is tuple. So what is tuple? So tuple is right. So what is tuples? Tuple is basically a list of items that you have, but they are what we call unmutable. You cannot change the item. So let me show you. So here we can see it's just a list of numbers, right? We have 4, 5, 6. You just have list of numbers and you sign it into a variable called top. Now, as you can see now, when you run them, when you click here, we can see that the tuples here, they are let me start this. Okay, so you can see here, we create a tuple, and the tuple here, you can see like we have numbers 4, 5, 6, but you can see here, you have braces here. So tuples are just used to store numbers, but those numbers, they are actually not changeable. You cannot change the numbers, or you cannot change the item. They are what we call, they are not mutable, as we see with the list. If you have a single item for tuple, for example, I have this, I said equals to, I have a single number. Let me assume that my tuple has a single number, which is 2. Now, this number, as you can see, I have only two here. And now when I have this, I run this. This is basically assignment of a number to a variable we call top here. But this is not a tuple. Let me show you this. Yeah, when I say, okay, show me what is inside here, we can see that this is actually a very an integer, right? Yeah, you can see this is integer. And now when we say, okay, give me what is the type of this, this is also it will show us this is an integer. But if you want to create a tuple with a single number, you need to put comma. This means that it is a comma like this that defines what a tuple is, not even the bracket. So here you can see here, we only use comma, but tuple are sometimes to avoid ambiguity. They are put in, oh no. So sometimes to avoid some kind of ambiguity, with tuples, we use braces to just bracket, to create a tuple. So here you can see here, I have a tuple, I have 2, and now let me run this. So when I run this, say what type of this is this, you can see this will tell me that this is a tuple. Can you see this is a tuple? Now, when I remove this one here, and I try to see what the tuple is, this will show me what tuple is. So let me run this. Can you see what it gives me? It gives me something 2 comma in. We have also this. So you can see this is just a single number, but it is a tuple. So what I'm trying to say is that tuples are created. Why this guy? My computer is so slow. I don't know why. Okay, just give me a second. I need to close some other stuff to make sure everything is okay. Just excuse me, give me a second. I need to okay. So let me okay. Sorry about that. I don't know why it's like let me open the stable version, my VS Code stable versions. So yeah, just give me a second. It's opening. So here, I think let me work with the stable version. Maybe in the other one, I have some issue with them. Maybe there's update that is trying to intervene. So you see, for the VS Code, you can have two versions. One of the VS Code you can have is called stable version, and the other one you can have is called experimental, in the sense that it has a lot of updates that you will actually right. Okay. Just give me a second, please. Does everyone read this chapter? Do you all read this chapter, or you have not? We have Muhammad. Do you read this chapter? Yeah, it's taking time. So anytime when there's update, this my VS Code tries seems to misbehave. So yeah. Okay. So VS Code. Okay. Right. Let me use my stable version of VS Code. The other one is misbehaving, so I think there's yeah. So what I was saying is, if you go to here, VS Code, stable version, yep, stable version. So you can see here, like when you go to VS Code, page, you can download VS Code. this is called a stable version, right? But when you go to VS Code, GitHub, for example, you see that you can actually download the development version, right? So yeah, you can maybe from here, you can actually the latest version, right? So you can download the latest version of it, right, and install. So the latest version, it contains the latest stuff that they implemented that is not available in the stable version. So if you are using this latest stuff, you see everything that VS Code is trying to release, you will be able to see it. They will not release it in this stable version unless everything is okay. But when you have that one, you will have the glimpse of having the important features lately before any other person sees. All right, so let me, yeah, you see, this is tuple. We created 1, 4, 5, 6, right? So as I said, oh, let me choose this, my kernel. Okay, so you see, this is called a tuple. We create a tuple here with 3 items inside it. And when I have this, I can say, okay, what this is tuple. I can have this top, a variable. I can, when I run this, you can see that it turns something like in this square bracket, right? So it means that a tuple can be created in 2 ways without even square bracket, just delimited by comma, or you can use square brackets. So this is a way in which tuples are created. So likewise, if you have a single item in a tuple, it must end with comma. So here, if you see, we have a tuple, which is 2. When I have this, you can see that this is tuple, right, with a single number but with comma. But when I have only 2 here, this is not a tuple. And now when I run this will actually give me an integer. So that's what is called tuple. It's used to store a list of items which are actually not mutable. It is often necessary to enclose values in parentheses for complex tuple. So you can see here, this is just a normal tuple. You don't necessarily use to enclose it, but for complex tuple, here you can see here I have 2 tuple, right? I have this and this. Now when I say, okay, let me run this will give me this is a first tuple, right? This is a second tuple. So you can see I want to combine them to create a tuple of tuples, right? Tuple, you can see, of tuples. So inside this tuple, I have 2 tuples. You can see what separate them is only comma. So that's why for this kind of complex stuff, we definitely need to use parentheses. I mean, yeah, I was saying parentheses to actually have this. You can convert any sequence or an iterative tuple. So you can also convert sequence or iterators to a tuple. What this means is that we all know this is a list, right? List is used, we use square bracket. Now you can convert it with a function called tuple, right? So here you can see, I can work on this and say, okay, convert this list to tuple. You can see here I have a tuple. But also you can see that I can have, no, sorry. I can have this, which is a string. This is a string. I want to convert it to tuples. So this will give me also something like this, taking a string, because this string is also a sequence of numbers. This converted it to tuple. So here also is a list that we have seen that you can actually work toward that to convert it to tuple. Element can be accessed. So for tuple, all the element inside a tuple can be accessed with square bracket, just like we saw from the list. So here we can say tuple of X, because our S, remember what is S, what is top. So we can see here, this is our tuple objects, right? Yeah, S, stuff like this. And now when we say top of 0, this give us this. So we can actually access the item inside a tuple. So one thing we should know is that tuples are not mutable. So what this means is that tuples are not mutable. You cannot change the item in tuple. So this is a tuple. You can see this is a list, right? And now this list, I change it to tuple. So one good thing with a list is that it can contain many items. You can see this is a string. This is a list inside a list, and this is a Boolean. Now, you cannot actually try to say that you can update the value inside a tuple, saying that tuple false to set the value. So you cannot do this, right? So this is one good thing we should know with tuple, that we'll see something different when we come to list. So we should know that tuples elements are not mutable. That is, you cannot change the items inside the tuple. But one way you can actually, if the items inside a tuple is mutable, so because list is mutable, then I can update content of this list. So if an object inside a tuple is mutable, such as list, you can modify it in place. So here you can see I say tuple of 1. So I'm referring what is tuple. Now we have a tuple. This is the first item. This is the second item. This is the third item. This is the index of this is 0. The index of this is 1. So I can actually append, that is to add something inside this list. You can see tuple of 1 dot append. When I say tuple of 1, let's see this, what will happen. Tuple of 1, what will give us? Tuple of 1, can you see this is what it gives us? It gives us this top. So now I can say this append 4. Yeah, can you see that inside the list, we actually do append. So if an object inside a tuple is mutable, such as a list, you can modify it in place. So now here we modify. So the basic idea we should know is that you cannot modify the content of you cannot modify the content of a tuple. But you can also concatenate tuples using addition operator. Yeah, so this is a tuple, this is a tuple, so we can actually concatenate it to see what the content is, right? You can see here they are concatenated, but also you can actually multiply the tuple. You can see here this is a tuple. We multiply by 4. You can see. So these are some of the operations that you should know all about tuple that basically you can achieve with tuple. Now, there is what we call unpacking, tuples unpacking. If you have any question, please ask, but these are some of the things we have seen, and we are just brushing them off. So this is a tuple, right? Now, what about if I want to assign content inside a tuple to different objects? So here, for example, I want to assign 4 to A, 5 to B, and 6 to C. You can do this and say tuple and provide the item you want. This is called tuple unpacking. Yeah, this is what we call tuple unpacking. Can you see that the first A here is assigned 4, B is assigned 5, and C is assigned 6. This is called tuple unpacking. All right. Here we can see it's still a tuple, right? We assign this a tuple, and now here we say, okay, tuple, we assign A, B. A, B will be 4 and 5, and C and D will be this. So let's run this and see what will happen. So here you can see A, D is 7, right? This means that A is assigned this, B is assigned this, and this is now a tuple. The tuple, you can see it assigned this tuple. So these are some of the operations for the tuple we should know. But also one good thing with tuple is basically when you want to change the items inside the tuple, when you want to do what is called swapping. So in normal, our natural way of doing programming in other language, if I want to swap some item, for example, I have A equals to 2, and I have B equals to 5. Now, if I want to swap A and B, what I can do is this. I can say, okay, I create a temporary variable and assign it to A. Then I say B equals to A, and now I assign this temporary variable to B. So this is how you can achieve, let me show this. So this is way to achieve the, and when I say what is the value of B, you can see that the value of B is now 3, right? When I say what is the value of A, you can see the value of A is now 4. So this is basically some ways to do, to actually, what do you call it? To change item from one object to another.
Swapping.
Swapping, yeah, good one. Swapping. So this is one way to swap stuff from one variable to another, but you can do it with the list, with the, what do you call it, with tuple in a beta way. So what this means is that, let me run this. So here you can see here we have 1, 2. All right. A is 1, B is 2. So let's look at something here. So we know this. So with tuple, since you know A and B, you don't need to use this creating a temporary variable. You can just swap this stuff, right? So you can just do something like this. So now you can see, you now just swap the variable. So you can see tuple allow us, but with, for example, if you don't have tuple, you cannot do this because this is tuple, right? This items is tuple, and this is assignment. So this means that this is tuple your assignment. So you can see here when you say what is B, you can, yeah. So this is basically one thing you can do with tuple. Yeah, just to know. Right. So there is another thing here. A common use of variable unpacking is iterating over a sequence of tuples. So one thing, one of the common use of variable unpacking is iterating over sequence. So for example, here I have a sequence here, and inside this sequence, I have a tuple 1, 2, 3, right? Now I can go over this sequence and do some stuff. So I can say for A, B, C in sequence, print A of 0, B of 0, yeah, and print ABC. What is basically doing here is printing ABC. Let's change this guy to, okay, you know the format way, right? A will be assigned to A, B will be assigned to B, C will be assigned to C, but we can use F string, but here the book is not using F string. That is why I didn't do that. So who can tell us what do you expect this output to be? What do you expect this output to be? So we said for A, B, C in seq, right? This is a seq, right? So we want to iterate this. What do you expect the output of this one to be? Okay, so when we run this, so you see A equals to 1, B equals to 2. So it means that this will go for the first one here, because this is a sequence, the first tuple, the second tuple, the third tuple. So you say, okay, for A, B, C in seq, that is a seq will take the first item here and now assign A, B, C to this item. And now we'll print the item here. It will go over to the next one. The next one in the sequence is this item. The next one in the sequence is this item. So this is one way to do unpacking. So this is a lot of other things we should know. Yep. Another thing is Python introduced what is called rest. So for example, here I have a tuple. Yeah, this is a tuple, right? But I want to only now assign the first 2 items to A and B, and I don't want this item, the third one. I want to discard the rest. In a nutshell, how can we assign some part of tuples, not everything in the tuples, to a variable, to some predefined variables? So here, I want to assign only 1 and 2 to A and B, but I don't want the other items. So if I do this, for example, if I do this, okay, values is this, and now I say, okay, I have this. for example, and now I have this. So I say, okay, let me assume that, okay, let me assign only the first one and the second one. Therefore, A will be 1, B will be 2. And now the rest, since I didn't assign it to anything, then they will be up. So what will happen if we do this? So you can see you can get an error because there are still some remaining stuff from this tuple. You need to assign them or tell the tuple that I don't need them. So that is it. So for you to tell the tuple you don't need the other stuff, you don't need the 2, 3, 4, you can do this thing, right? You can put star and you say rest, something like this. So when you do this, it means we are telling this that run this. Okay, so we have this. So let's look at it. Now, what is A and B? So when we run this and we see what is A and B, so you can see A and B are 1 and 2. And now what is rest that we already assigned? Let's see. You can see the rest is 3, 4, and 5, right? So this is one way you can use to assign multiple stuff from tuple, multiple item, because this one variable, this assignment, you can assign a single item from the tuple to A, B. But if I want to assign this 3, 4, 5 to a single item, you can do this format. But using the rest stuff is not something that really special. So this rest bit is something you want to discard. There is nothing special about the rest name. As a matter of convention, many Python programmers will use this underscore for unwanted variables. So for example, we don't need these variables 3, 4, 5. I just want to extract A and B. I don't want others. So you can just put this underscore. So underscore, you can see that you are not assigning anything. So you can run this. So this will run. So it means now here you have your A and B, and you can move ahead if you are using your in your program you want to use A and B only, so you don't care about the rest. Yeah, so that is how we can work with tuples. Any question before we continue? Hello, any question? Okay.
Yes, I have a question.
Yes.
So imagine you want to maybe assign some parts maybe in the middle. Maybe we have like a sequence of maybe 9 numbers. So I want to maybe assign those in the middle.
Good question. Yeah. Okay, so let's look at what's Falalu is saying. So Falalu was saying, like, maybe I want to assign 1 to maybe 3, 4, and 3 and 5 to a single stuff. So let's do this. So you see, you cannot actually. I'm not sure if it is possible. So for example, Falalu, what is saying, can we have something like this? Well, here we can specify the items we want to assign. I'm not sure how this. Let me see. I mean, rest is not something specific. You can do anything. But so further, what he's saying is that can we assign A now to this, and now 2, 3, 4 maybe to a variable in the middle, and 5 to this. Is this the question, Palalu?
Yes, sir.
Okay, so I'm not actually sure that how we can actually, because the issue here, the previous one we did, when you put star, it means you mean everything from the rest, right? But here, when we put star, I'm not sure how we can specify that text from particular position to particular position and assign it. I don't know how, because when we run this, actually, I know it will return. Okay, let's see what this will be. We have A. So what is rest? Let's see what is rest. Yep. We have rest. I think this rest will give us the whole stuff. 2, 3, 4. And B, I'm not sure if this guy works as a, no, let me change this one. Let me change to make sure what this guy works. So let me change it to 6 here. So you can see here I have this. Let me see my best rest, right? Rest. Okay, so let's look at it. 236. Yeah. So this one works, but I'm not sure how it knows to assign only this stuff. So yeah, so I think there's something. So for example, here you can see that because here we said B will be assigned to only the last item. So let me say we have another items D here. So this will assign only 2 and 3. 2 and 3. So the Python is so intelligent that it will know that there are 2 items will be assigned B and D. So, and A is assigned here. So anything that is in the middle, that is the rest, assign it to the variable rest. So let's look at this, how it will work. So let's see. So what is rest? Rest, what do you think will rest be? Who can? Rest will be what?
Will be a list of 2 and 3.
Yes, 2 and 3. Let's look at it. Yeah, can you see 2 and 3? And B, here you can see when we have B, this will give us 6. When we have D, this will give us this. Yeah. So yeah, thank you, Falalu, for raising the question. So this is one way you can do that. I don't know how it works, but just now trying to play with it, that I can see that the Python will try to even know that you have some remainder that you want to assign, and so whatsoever in the middle will be assigned. Yeah. Okay. Any question? Sadatu. So you can see all through the kind of this discussion and question, we all learn. I mean, yeah. So please do ask the question so that we can learn. Daradin. Ai ba ka tambaya yau kuma. Ko ba tambaya? Okay, to ba laifi. Okay. Okay, so it's all right. So let's continue. Okay.
Excuse me, sir.
Yes.
So what if you put rest, and you put rest, then AB, will it work? Like
yeah. It still work with the way we do, right? So, okay. Yeah, I get like this, right?
Yes.
Yes. Okay. So let's look at this. Yeah. So these guys will be assigned 365, right? These guys, and rest will now be. Yep. This will be this. So let's look at it. Yeah, 1, 2. Yeah. So this works. So it's good that we just communicate in this way, trying to understand. So please contribute to what we are doing and by asking questions so that we can learn more. So tuples method. So we know that every object in Python do have some kind of method. Not only method, but we know that list, tuple, set, they have method. So now we have seen some operation that we can do with tuple. Now we saw a lot of them, but the tuple as an object has some method, but because of the fact that tuple cannot be modified, it has limited method. Unlike list, when we come to the list, we will see a lot of method for the list. So one of the method for the tuple is just count, an example. So there are many other, but count will try to count how many 2 do we have in the list, right? So we can say a.count. Remember, for any object, for you to use its method, you use dot. Then you call the method and now put this. So it means this we count. So we have a lot of methods. So you can see here a dot. So you see it has only count. Can you see that? But we have also index. I think so. We can say index of 1. So let me use this. Can you see index of 1 is 0? Can you see that? So you see when I have this a dot, you see these are the methods 1, 2 for this object, which is tuple. But you see this one with dunder under them. They are not the method. They are something private to the object, which any object, when you create it, it has that. So these ones without this double underscore, they are the method related to this object. Yeah. Any question before we move on? before we move to the list? Any question? Palalu, question?
No, sir.
Okay, so now we have seen one of the widely used okay, okay, we now see one of the widely used data structure in Python, which is tuple. The next one we see is called a list. Now, what is a list? We already know a list, right? You see the difference between the list. Here is a list, right? And here is a tuple, right? But you can convert a tuple to a list, right? You can convert a tuple to a list. So this is state. You can see this, I have a tuple. Now, if I have this tuple, I can call a function method called list that can work on this. So this will change it to a list. So let's look at what will happen. So you can see here you have a tuple. Now you use this method called list to create a tuple. So there are many ways to create a list. Many ways to create a list. One, using this to create a list. Number two, using this method called list. All right. So if you have an items, you can create a list. Here I create a list. But if you have some other stuff like tuple, you can call a list method on them that will convert and create a list. So you can see here I call a list method on tuple. Now I have a list. All right. So this means that if I have a tuple here that I cannot modify and I want to modify this tuple, I can change it to a list and now modify its content. So now here you can see, since the content of tuple is a list, I can now modify its content. So here I'm replacing the first position, the second, because Python starts with 0. 0, this is 0, right? This is 1. So I'm replacing bar with peacock, right? So you can see. So this means that because tuple, you cannot change it. So here, for example, if I have this tuple, so I have this guy, and I try to change it. Here I say, okay, tuple, no, tuple. I say, okay, tuple 1 equals to this guy. This guy. And now when I try to run this, you can see a tuple object does not support item assignment. So tuple object cannot be actually modified, but since you cannot modify it, you can convert it to a list and now modify it. So list and tuple are semantically similar, though tuples cannot be modified and can be used interchangeably in many functions. So you see, because tuple and list, they are semantically similar. What do they mean? They hold a list of items. Yeah, you can see list hold a list of items, this guy, then tuple also list of this. So you can see here, tuple also can contain. So can we have this tuple contain this, a mix of different kind of data structures? This is a string. This is an integer. You can see you have different kinds. So also here in the list, we can have this is something like this. So you can see when we run this. So both the list and tuple, they are semantically the same. You can use them in some ways, but the only thing is that tuple cannot be changed. So one way to use tuple is that assume you design a website and users now submit their password. Now, when they submit their password, don't store the password in a list, because somebody can come hack and change all the password, right? So you can submit, so store the password as a tuple. This means that the tuple cannot be modified, right? So this is just a simple scenario to just relate how you can use a tuple. So just a list and tuple are just the same data structure that can be used to store items. Right, so here I have something here, which is range. Right, so we have another function called range. So what does this range means? So this range actually return, let me show you this. Okay. Type. Okay, so this is a function called range. And as we can see here, we put 10 inside it, but when we call it, it shows us 0 to 10. So what this range function does is that it stores items from particular items. So this is the same as this. This range is the same as a list like this, from 0, 1, no, 0, 1, 2, 3, up to 9. This one is the same as this. But the problem is, if I want to create a list with 1 million items, do I need to write something? I say 1, 2, 3, 4, 5. I should write up to 1 million. Can you see that this is not feasible? Now, for you to do that, we have a better way to create a list without listing the items. That is called a range function. So if I want to list 1 million items, I can say 1 million here. Then when I have this, then you can see here, this is 1 million, from 0 to 1 million. The advantage of the range is that it stores less memory, in the sense that here it stores only 2 numbers, 0 and 1 million. And everything here, if I have a list, for example, I have a list of, I have a list here, 1, 2, 3, 5. And I have range 1 to 5. So what this means that in this list, these 2, 4, they will all be stored in memory. But when I have a range function, only 1 and 5 will be stored in memory. But since it is a range function, it's know that it starts from 1 and stop at this last one, 5, even though it's not included. So it is memory efficient to use a range object to store an items. So you can see here, this is a range. When I say what type of this is a range type, but you can convert the range to the list. So here you can see that we can use list to change it to a list item. Yeah, so that is basically what this range does. We will see a lot about the range function. Just for you to know is that the range function just store list an item, but we just provide the item. But one thing you should also know that when we have a range, we provide a single number. What this means that it will start from the 0 to that number, 0 to this. But you can provide where it can start from 1 to 10 like this. You can say, okay, from 1 to 10. And now you can see that here I have a range of number from 1 to 10. So you can see when here I have a range, you can have a range, right? Yeah, so that is range function. Now, adding and removing elements. So let's look at different kind of method that can work on a list. Number one, you can add items to a list using a method called append. So we already have our list called B list here. This is a B list. When we run this, and this is full this, right? This is a list, right? Now we can have add item. We have append method. So this is append method. You can see the append method actually add this drop at the end. So, but you can insert items from the list given position. So here you can see append add at the end, but you can say, okay, put at position 1. So we can use this to actually add at position 1. So you can see here the red is now inserted here. That is it. So insert is computationally expensive compared with append. Why insert is computationally expensive? Append I touch only at the end, but when I want to insert at this position, every items now must be shifted to a particular position. So it is computed. It takes much memory to do that. We also have inverse operation of insert, which is pop, that you are popping the item at position 2. So here, when I have this will pop actually pick up, because this is for 0, 1, 2, position 2. You can see it pop this. All right. So that is pop operation. And you can also remove an item. So we can see still you can append. This is the method we know. Now you can use the method called remove. So you remove full, you remove this full, yeah. So we can use many other operations with the list. We have what is called membership operators. So we have membership operators in and not in. So in is a membership operator that tries to see whether something is inside a particular list. So we can see, is it drop inside a B list? If it is true, it will return yes, it is inside, right? So you can see it is inside, but not in. Dwarf not in. What will happen? This will say or tell us this is false because dwarf is inside the list. So these are some of the operations that can be performed in a list. We can also actually similar to tuples, we can concatenate lists. We can this is a first list. And this is a category, we can concatenate them to give us a very large list, right? So this gives us a very large list. So if you have a list already defined, you can append multiple elements to it using extend. So for example, now I have a list, right? And now I want to extend it rather than here using the concatenation. So you can see here we have 4 non-full, we have 7 here, we can concatenate. But we can use a method called extend, which will extend this list now to have this. So let's look at it. So you can see here that if you have already a list defined, which is this, here you can see I just have the 2 lists. It's not defined. I have not stored them in any variable, but here I have a list defined inside a variable. Now I can extend its content. So you can see here I have 4 non-full. I can have this and extend its content. So these are some of the methods that we should also be familiar with, because when we come to the data analysis, we'll be using them. Right. Any question before we move on? Any question? Okay, let's move to another method. There is a method called sorting. So we can sort the content of a list, but the content of a list is the sorting is performed in what is called sorting in place. So this is a list, and I want to sort its content. So I can call this method sorts. Right? You can see that you sort the content of the list. But sort, you can see this stuff. It's what we call sorting in place. It sort A automatically. You cannot do this. For example, you cannot say, okay, sorted. You cannot say, for example, you can create a sorted a variable that you cannot call that sort method on an object and assign the result and assume that the result will contain the sorted object. Now let me run this. Can you see that? So let me see what is sorted. When you run this, this will give you, okay, it gives me nothing, which is none. But let me call this print on this, print this. So when I said print the sorted, you can see it gives me none. So what this means is that the sort method return none, but it already modified A. The modification is done is that in place. That is what we call modification in place. Without creating a new object, it will modify this in place, but will not create a new object. I don't know if I'm making sense about the in place. Do you understand what is meaning of in place? Any question with the about in place? Okay, so if we understand what means in place, so sort key will actually have a parameter sort that that you can sort based on the parameter. So sort here, you can see we said, okay, key is a length. So this means that this will, so I have an items here. I have so small, he, she, right? And what is the length of this is 3. What is the length of this is 5. What is the length of this 2? What is the length of this 5? So I can supply a key, which will actually sort this based on the length of the key, the length of the stuff. So here you can see this is a length, which is a function. So it will actually try to find what is the length of this. What the length of he is 2, then it can you see? So it sorted based on the length, right? So this is one argument that you can provide with the set method. Any question? Okay, right. So we have also what is called Bisect Module from the built-in Python, which basically you can see here is that we have I import bisect here, and now I have a list, right? Now I say bisect which because I import the module this way, bisect, there is a method here inside the bisect. I said, okay, C2 tells me this is the list, tells me where is the position of this. So you can see bisect module implement binary sort, which insertion into a sorted list. Bisect, I said, find the location where an element should be inserted to keep it sorted. So you can see here, I have 1, 2, 2, 2, right? So where in the list can I insert 2 to leave the list sorted? So it will tells you at position 4. So you can see 0, 1, 2, 3. The next item is position 4. It tells me it's position 4. But in sort, it will automatically not tell you the position, but will insert the item in that correct position. So you can see here in sort set as 6, right? So this is a convenient module which comes with Python battery included that actually allows you to do this stuff. Okay, the next thing we can see is slicing. So what we saw basically is just a method to work on Python on the list, but we can do what is called slicing of a list. Slicing basically try to take some parts, taking some part of a list. Now, assume we want to take from here to, for example, here, then we can use this something. I can use square bracket and put this, and now use this format. You can put it start, stop. Where is this? I don't know. Okay, so basically this is the format. You can put the starting index and now the stop index, right? So here, what do you think this will give us? Who can tell us what this will give us?
It will give us 2, 3, 7, 5, 6.
Hmm?
2,
Okay.
3, 7, 5,
Okay.
6.
Okay.
Why 5? Oh, yes.
Yeah. So it gives us, because you remember, if we are doing the slicing, the last item is not included. So 5 is not included. It will give us item from 1, 2, 3, 4. So you can see this is index 0. This is index 1. It starts from the 2, 3, 4. Right? It will not give us the item from 5. Index 1, 2, 3, 4, 5. So the last one, which is not included. So what it does is that it will give you the item. You can say 5 minus 1. 5 minus 1, it will give you 4 items. Yeah, if you want to know the item 5 minus 1, it will give you 4 items. So yeah, do you understand what I mean? Hello? Do you understand this? So
Yes.
okay, no question. Any question? Or is it confusing?
It's not.
Okay, so we can assign, also do assignment. So here from 3 to 6, I want to assign the value this. So you can also use slicing to assign some values. So I can update the content of the list using this one. But the list, you can leave the starting to be empty. This means that you are starting from the beginning. So here, if I have this empty and I have 5, who can tell me what will be the result of this? What will be the output of this?
It will be 7, 2, 3.
Okay, let's look at it.
6.
Yeah. Yeah, because 1, 2, 3, 4, 5. Why? Because this counting start from 0, right? 5 minus 0, right?
Is 5.
Beginning, yeah. So that is why. You can also have the item, the last item excluded. It means start to the end. What will be the output of this one? Who can tell us?
Six, 3, 5, 6.
1, 2, 3.
Okay.
6, 3, 5, 6.
Okay.
6, 3, 5, 6, 0, 1.
Yeah. So that is it. Right. So we can have what is called negative indexing. So what is negative indexing? So here it says start from -4. This is telling us start from the end. So here it means this is okay. How list is numbered is this is position 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. We are counting from this. But when you are counting from the left to right, how can you left to right? Daga nan zuwa nan me ake ce mishi? Haka zuwa haka. Left to right ne ko me?
Yes. Left, right.
Okay, then this start counting from not -0, -1, not -0. You can see here the index here is 0, 1, 2. Let me show some example. Index
I say -1, that means last
index list. Yeah, okay, yeah. So this is list indexing. You can see this one start from 0, 1, 2, if we are going, but if you are counting from the end, from the last end, it's -1, because -0 is still 0, right? So you cannot have -0. So -0. So you can see it start from -0, -1. So this means that when we want to do our indexing with 0, what do you expect this one to be? It starts from -4. So this is -1, -2, -3, -4. So it starts from here till the end. So what do you expect? What will be the output of this one? Who can tell us?
It's 3, 6, 3, 2, 7.
It's 3 what?
3, 6, 3, 2, 7.
But okay, where it start from where? Okay, this is -1, this is -2, this is -3, this is -4. So the starting point is this, right? Now, this is the start. What about the stopping end? When we have empty, it will go this way or this way.
Up to the end.
Why is the end? This is the end here or haka? Or to here?
Towards
Left.
7.
Left. 7. 7.
Towards 7.
But here,
Yeah,
remember,
7.
but here, remember here, we don't actually say it's minus. This is the starting that is for minus, but this ending is not counting from minus.
Yes.
The counting here,
7, 2, 3, 6,
it's not
3, 5.
okay. But here, look at it here. When I say start from 3, where is it? Okay, start from 3. Go to the end. Where is the list? This is a list. Let me show you this. Okay, let's see this sequence. This is sequence. Yeah, this is sequence. And say sequence start from 3 to the end. Where is 3? 0, 1, 2, 3. That is start from 6 to where? End. Nan ya tafi aiko?
Yes.
So
yes.
kun ga nan ai da muka bar shi empty, it means to the end. This is the beginning of the list. This is the end of the list. So what about here? I said start from the beginning, -4, but the end. So let's look at it. What do you think? Who can tell us?
N is 7. It will be 7, 2, 3, 6,
Okay.
3, 5.
So do we all agree?
No. No.
No, sir.
No. I don't agree.
Eh?
Sir, it will
I
read
don't agree.
3, 2,
Okay.
Oh.
So let's see what will happen. So you see, this is not true, Malama. And when we say start -4, it means this is -1, -2, -3, -4. That is the starting point. But go to the end. This is the end.
Okay, right. Okay.
Yes, because I am -0, -end 0, minus something like that. Normal, we say this one here.
Okay.
Yeah. So yeah, something like it. But what about this one? Who can tell us this one?
-6.
Malam Amurja, tell us.
-6.
What will be this one?
-6, -2.
Yes.
Where is 6?
So minus is -1, -2, -3, -4, -5, -6. So it will start from 6, right?
6, yes.
And now stop at where? -2. Where is -2? -1, -2.
It's
So this is 6, 3, 5, 6.
the 6 there. 66, 6, 3, 5, 6.
Yes. So
6,
do we
3, 5,
understand
6,
this?
6.
Yeah. So that is it. Do we understand this?
Yes.
Okay. But what we have seen previously now is just by default, we don't have, but you can have another thing. You can have start, stop, and step, increment. So for example, here you can see here, I have my seq here. My seq is this. All right. This is my seq, right? But I want to move, like I want to slice this. Give me from here, when I put this from here starting, then to the end, but there is something, look at it, start, stop, and step. That is every after 2. So this means every other 2. So here give me 7 and 3. So let me run. Oh, okay, this is it. So this, let me show this. So can you see that by default, step is 1 if you don't include any step. So when okay, let me remove this. So what is this? Oh, what is this? Can you see it gives me the same list, right? The same list. Can you see the same list? It means by default, we have 1 here. It means it giving me the sequence from moving from just 1, that is one, I mean, without any step. But when I see, for example, 2 here, it means it will give me the list with some kind of increment. So this means that it will look at this. I have this, then 1, 2, then it will give me another one, then 1, 2, right? No. 1, 2. Can you see this one here? It will not give me the middle one, right? And also here you can see it will not give me the 6, it will give me 3. So there is what we call step that you can specify to actually, to actually report your stuff. And you can revise the list. So this is one a good way to reverse the content of a list. That is start from the beginning to the end, but start from -1. So this is one way to actually reverse a list, one trick way to reverse the content of a list. So there are many operations with this slicing. I can, inshallah, share a practice that we can use regarding to using the slicing so that it can nail into our memory. Yeah, so now we have seen some actually some function with the list. Let's look at built-ins. Let's look at some of the functions that actually works on what we call sequence. So any question before we continue? Any question? Okay, if there's no question. So this is a list I have. Now, assume that I want to report the content of the list and it is position. I can use what is called enumerate. So here I can say for X, Y in enumerate, I put the list, then enumerate will give X and Y the position and the content. Let me show you what happens. So when I say enumerate list, when I say enumerate and I give it any kind of sequence here, this means that the first item that I call here will be the position. And the second item will be the content of a list. So what is the position of foo is 0. Can you see? Index. And now because here I'm printing inside X, which is the index, and Y is the content. So here you can see it gave me this. So enumerate is a kind of function that keeps track of the index of a sequence. So you will see the enumerate in some ways as you continue working with the later. So yeah, any question on enumerate? Anyone with question on enumerate function? So as I said, enumerate basically keep track of the index of what we have. Then we have a function called sorted. So what sorted does is basically it sort the items in a sequence, just like sort, but sorted can be assigned to a variable. It does not change in place. So if I have this, What is happening? Sorted. Anything with this? I'm not sure what is happening here. Okay, let me see something. Sorted this guy. I have a list. 1, 2. Okay, let's look at this. Sorted name type, non-type. What do you mean by non-type? This should supposed to work. I don't know what is happening. Non-type object cannot be callable. I don't know what is happening, but this is supposed to work. Let me look. As oh, you mean to say something like this?
Yes.
So let's look at it. Yeah, this is not the problem. Non-type object.
Okay, I thought some at the end of it is where sorting is from.
I don't know why this doesn't work. It's supposed to work. Okay, let me see this. So maybe something is wrong here. I don't know.
It
but
should work.
yeah, it should work. Yeah. Do you have computer?
Maybe you need to restart.
Yeah.
You need
Okay.
to restart.
Maybe let's restart the
control. You should press control shift. Control shift.
You want to restart the debitor? Yeah. Yeah. Do you want to restart the debitor? Yes. Let me start the debitor. Let's see. Okay. I restart the debitor. Let me see this guy. Yeah. So I don't know what happened before. Yeah, so this works. So you can see here we have sorted. So sorted can be assigned to a variable, for example, can be doesn't sort in place. So we can use this sorted here. And now we can call the sort here as here. Yeah, you can see we can. So if you want to sort the results on variable, you can use this. But also you can, okay, if you want to sort in reverse order, you can provide an argument that sort this, but you want to sort it in reverse order. So this sorted in reverse order. Here also you can see we call the sorted function on this and it sort this stuff. So that's one of the function of sort. Let's look at what another thing, what is called zip function. So the function we already saw it in some of our session, basically given a list here, list 1, we have the list 2. When you call a zip function, what is basically does it that it takes this and this and merge them. But when we have the zip function here, it returns what we call a zip object. So to actually turn it into a list, we need to call a list function on this method on this zip object. So you can see here it zips. So here we have seq1, seq2, but I call zip on this. So it will return seq1, it will call foo and 1 here. You can see it here. It can take this one and this one. You can see that this is what is called zip, right? And zip can take an arbitrary number of sequence, and the number of element is produced determined by the shortest. So zip can take arbitrary number. So you can put like 3 items. So you can see here I create another sequence, but this sequence, remember, it has 2 items, right? But the other one has 3 items. But what will happen now? So the resultant one will contain only 2 items. So here we'll have you can see here we have 1, right? And because we have 2, it's added. But you remember this, the previous one, they have bars and 3, but they are not included. So this means that zip can take arbitrary number of sequence, and the number of element it produces is determined by the shortest sequence. So if, for example, here I have another thing here true in this one. So you can see the items now, they all have three items. So when we zip, it means that you can see it have all three items. But when you have one of the list has two items or less items, so the list of the other one will be discarded and only use the list, the length of the smaller one. Yeah, any question? Right. So a common use of zip is simultaneously iterating over multiple sequences, possibly combined enumerate. So one of the common use of zip as well is sometimes we combine it with enumerate. So here I have zip, seek, and seek, right? And now I say, okay, I call enumerate on this. So you can see when I zip seek 1 and seek 2, let me show you. Because all this kind of stuff, you will be seeing them in the future. So for example, here as you have zip seek 1 and seek 2. Okay, let me call enumerate here. Oh, okay. I mean, list. Yeah, we see what this happen, right? This is what happens, right? So now we can actually call enumerate in the same stuff. Then this means that it will take care of the index here if we call enumerate, and now the item. So here you can see for I, then this is a list and this is a tuple. In enumerate this, it means I will take care of the index and AB will take care of the tuple inside. And when we run this, we will have something like this. Can you see that? This is the index because here I put this and here will be the A and B here, A and B here. Can you see that? So this is one way to use the list. Right. So given a zip sequence, zip can be applied in a clever way to in zip sequence. So for example, let's look at another application of zip. You can see here you have list of items, list of tuple. We have 1, we have 2, we have 3, right? Now, then I have what is called the zip, and now I have this list. I have this star here, and now I say zip on this stuff. So what will happen here is that I have first name and I have last name. So this is a first name in the tuple. This is a last name. This is a first name, last name, first name, last name. Now, so I want to actually zip this stuff so that I have, we already saw how we can use what is called tuple unpacking. So this means that we can actually assign all the first name here to first name, and all the last name to last name using this zip and this. So here, when we run this, you can see the first name is here. Can you see that? And the last name is here. So this is a clever way, as they say, to actually do this stuff. We can also use a function called reverse, which actually we know what range is. So reverse actually reverse the content of the list. So here, yeah, we can say reverse and we can call the list. So here, for example, it's a list of 0. You can see range of 10 is 0, 1, 2, 3 up to 10, but I call reverse on it. But the reverse itself is an object, it's a generator. We will discuss this later. So reverse itself is a generator. You can see what is returns range iterator, and you need to call a list on top of it to actually show the real content. All right, so that is about the list. Any question? Any question, Madam Amurja?
Yes, doctor.
Any question?
No question.
Okay, so let's quickly look at the dictionary. So dictionary also we already saw in our previous session, but it's good also we revise them. So you can see, as I said, dictionary is the most, maybe the most important built-in Python data structure. So you see, they say maybe the most important built-in Python structure. Why they say that is because as we saw in a list can only store a list of items, but we can model real life object, real life scenario with a dictionary. So it's somehow more important some others. So here it's used to define a dictionary, empty dictionary. So this is empty dictionary just with the curly braces. This is a curly braces, but the item in the dictionary are defined in this way. So this is so for example, I can say, okay, this is a dictionary. I can say this. I can have this. I say, okay, I can save what can I say? Okay, I don't have anything on top of mine. Let me just go with this. So this is how it does. Now you can have your key here and you have the values here. So this is a key, this is a value, key value. So dictionary is a key value container. This is a key and this is a value. So with the value, you use this semicolon to provide the value. So when we run this, what the D1 is, you can see this is a dictionary, key and value. This is a key and value. You can actually update the or the element of the dictionary. So here you can see we say D7 and integer. So what this means, let's say that. So you can see this one here. You can actually add more stuff to the dictionary. So here you're adding 7 to be the key. Can you see 7 is key and this is a value. So this is basically, you can see here is a way to actually do that. But when you compare with the list, so for example, I have a list, A equals to, in a list, I have 1, 2, 3, 4. Now, when I say A of 1, A of 2 equals to 6, what will be A? Who can tell us what will be the A? What will be A? What will be the content of A now when I run this one? A previously A is 1, 3, 4, right? But now I say A of 2 equals to 6. What am I doing? What this operation is doing? What this operation is doing?
I think we are overwriting.
Yes, we are overriding the index as 2, right? You can see it's 6. So this is overriding when it is what? List, right? This is a list. But you can see the same operation, similar operation in a dictionary. Dictionary we are adding. Here we are adding. In dictionary we are adding item. So here you can see I say this, what I'm adding. Here in a list, this is a index. And this is item you want to substitute in that index. But here this is a key. And this is item you are assigning for that key. Yeah, so you can see this is one of the difference between the dictionary and a key. And here I can say D1 of B. When I D1 of B, I'm trying to assess the content, the value of key B. That is, you can see this is a B. What is the value? So D of B, you are assessing it is content, the value. The same with the list we saw with tuple and list. You can check if something is inside a dictionary. So you can say B in D1. So this is true. Yeah, because B and B should be a key. Can you see B in D1 is a key, right? Yeah, does this key inside a D1? Yes, it's inside. Yeah, you can delete also some of the stuff. You can delete value either using the delete keyword or pop method. So let's look at this one here. We add some other stuff. You can see I had a key, some values. Here I have another key called dummy here and another value for that. Here you can see that. Now I can delete something from dictionary using delete keyword. So delete D15. Now it means I'm deleting D15. So what will be deleted now? So D15, the key here that I provided, is now being deleted. So you can see know that one. I can also remove with pop. I say key. So you can see this one is pop method to remove, and this using delete key. So I can say D1.pop. I provide the key. So here you can see I have a key called dummy. When I run this one, I now remove it. So you can see here. Now when I run this one here, yeah, so the difference between a pop will return the value that has been removed, but delete will not return the value. It will just remove the item in the dictionary, but the pop will remove the item and return it. That is the difference. We also have another method called keys. and the method keys will give you the keys in the dictionary. So when we run this, will actually give us a key on the dictionary, right? We have A, B, you can see we have A, B, and 7. These are the key, right? And what is the type that returns here? That is a dictionary key. So let me show you this. What is it? So you can see this is called dictionary key. So what this output is not a generator, it is not a list, it's called dictionary keys, right? It's called dictionary keys. It gives alternative of dictionary keys. So if you want it to return the keys as a list, we can actually call a list. Oh, we are, yeah, okay. It is already 4. We can stop. Okay, let's find time so we can see that list that dig the key, it will give us a key. We can also say, okay, if we don't want to return a list, we want to return a tuple, we can call a tuple on that. So when we have this will return a tuple, right? Let's find a way to stop. And we have another method called values. So values will actually return the values, not the key. So here we saw that we return a keys, but calling a values will return a value. So you can see here it returns a value, not a key, right? It returns a value, not a key. Yeah, so you can also merge one dictionary to another using the update method. So with a list, we saw a method called extend, but with a dictionary, you can use what you call update to update the dictionary. So here I have already existing dictionary called D1, which is this, but I want to update it, add more with this, so we can use update, right? So you can see here it added. So in list, we use extend method, right, to update the content. So yeah, the update method sends dictionary in place, so any existing key in the data. So yeah, right. So we are running out of time. I think we can stop here. This means that this week we can only cover the chapter 3 maybe. So tomorrow we will try to continue. If we have more time, we can continue with chapter 4. Yeah. It's already now time for prayer. Yeah. Okay. Any question before we go? Yeah. Any question? So please try to see that you practice this concept, because when you just listen, it may not stay in the memory, as I always say. So just try to see that you practice what we did. I will push this to the GitHub repository, so that if you want to see it, you can go. Oh, I try to even to do how we can clone GitHub repository. Maybe tomorrow I will show us, before we start doing the session, I will show us how to clone GitHub the repo, so that you may know what is happening, how to do that. Yeah. Any question? Git push. Any question? No question?
No question.
Okay. If there is no question, then we see tomorrow. I will push the stop right now. Then you can have access to it. Yeah. Okay.
Okay, thank you.
All right. See you all. Bye bye.